Here we have an ellipse with the focus at the points 6, 0, and the vertices are at the polar points 8, 0, and 8, pi. And what we want to do is write the polar form of the equation of the ellipse. And so notice that for this particular problem, the focus is not at the pole, or the point 0, 0. So far, we have only deal with problems where the focus is at the pole. And so for this particular one, the focus is not at the pole. And so we want a polar form of the equation of this ellipse. So first, let's go ahead and convert these polar points to rectangular points. And so we use the formulas x equal to r cosine theta and y equal to r sine theta. And to convert the polar point 8, 0, we have x, this is r, this is theta. So r is 8, theta is 0. So we have x equal to 8 times cosine of 0. Recall that cosine of 0 is 1. So 8 times 1 is 8. And then y is r sine theta, or 8 times sine of 0. And sine of 0 is 0. So we get 0. And therefore, for the polar point 8, 0 is also 8, 0 in the rectangular system. And similarly, for the point 8 pi, we worked it out, it come out to be negative 8, 0. Recall that for the conic section in general, or in this case is the ellipse, C represents the distance from the center to the focus, and then A represents the distance from the center to the vertex. And so let's go ahead and plot these vertices, and so we can locate where the focus, and then we can also locate where the center is. And so for this particular example, we have the vertices at 8, 0, and then we have the other one is at negative 8, 0. And then we're also given that the focus is at the point 6, 0. And since this is vertex number 1, this is vertex number 2, then the center has to be at 0, 0. So the center is at 0, 0. And so C is the distance from the center to the focus. So the focus is at 6, 0, and so the distance from here to here is 6. So C is 6. And then A is the distance from the vertex to from the center to the vertex. So from center to vertex, distance is 8. And so this is 8. And again, the center is at 0, 0. And recall that for the ellipse, the relationship between A, B, and C is A squared equal to B squared plus C squared. And therefore we get 64. 8 is 8, and so A squared is 64 equal to B squared, and C squared is 36. And so B squared is 28. So minus 36 minus 36, and we'll get 28. And since we have the vertex here, and so obviously this ellipse is elongated horizontally like this. And so the equation of the ellipse will have the form x squared over a squared plus y squared over b squared equal to 1. So in this case, we'll get x squared over 64, a squared is 64, and then b squared is 28. And once again, our objective is to get the polar form of the equation. And so this is the rectangular form. So this is the rectangular form of the equation of the ellipse, but what we want is the polar form. And we know that x is equal to r cosine of theta, and y is r sine of theta. And so this is the same as r squared cosine squared, and this would be r squared sine squared. And here we have a common factor of r squared, so let's pull it out. So we get r squared times this expression equal to 1. And so let's combine these two right here, and so we can cross multiply. So this is the same as 28 times cosine squared plus 64 times sine squared, dividing by 64 times 28. And then now let's multiply both sides by the reciprocal of this. So multiply the left side by the reciprocal of this expression. This is what the reciprocal looks like. So we're multiplying the left side, the right side by the reciprocal. And so obviously this expression multiplying by this expression is 1. So r squared times 1, it is r squared, and then we get 64 times 28 over 28 cosine squared theta plus 64 sine squared of theta. And this is the polar form right here, but let's go ahead and simplify it a little bit more. So let's go ahead and divide the numerator and the denominator by 64. So divide the numerator by 64, we get 28. And then divide each term in the denominator by 28. So 28, not 28, but 64. So divide everything in the numerator by 64, and then divide everything in the denominator by 64. So we divide the denominator by 64, we get 28. And then 28 dividing by, and then divide each term here by 64. So 28 over 64, and then 64 dividing by 64 is just 1. And then let's put the sine square in the front here, just move it. So we're just moving the sine square and put it before the cosine square. And once again, recall that b squared is 28, a squared is 64, c squared is 36. And then the eccentricity is defined as c over 8. So in this case, it would be 6 over 8. And then e squared would be c squared dividing by a squared. So c squared is 36. A squared is 64. And so what we want to do next, so this is our polar equation so far. And so in the place of 28, let's rewrite it as 64 minus 36. Recall that this is b squared. And so b squared is a squared minus c squared. And so 28, just rewrite it as 64 minus 36. 64 divided by 64 is 1, and then we get 36 over 64. And now let's multiply this out. So we get 1 times cosine squared is cosine squared. And then we have 36 over 64 times cosine squared. So now we have sine squared plus cosine squared, which is 1. This is 36 over 64, or this is c squared over b squared. C squared over a squared, not b squared. And so this is b squared, and this is 1. Sine squared plus cosine squared is 1, and then this will be e squared. And so in general, the polar equation for the ellipse of this form, x squared over a squared plus y squared over b squared equal to 1. And then the corresponding polar equation will be r squared equal to b squared over 1 minus e squared times cosine squared. And similarly, the polar equation for the hyperbola of the form x squared over a squared minus y squared over b squared equal to 1, then the corresponding polar equation would be r squared equal to minus b squared over 1 minus e squared times cosine squared.